Dear student, I am Rakesh Chaubey from Sunbeam Sun City. My dear, today we will have a topic on reflection of, or I will get the reflection from concave mirror, reflection from concave mirror in my next topic. I will teach you a topic, reflection from convex mirror. So this is reflection from concave mirror, and this will not teach us only the reflection from concave mirror, it will give us a relation also, right? So we will going to get the relation also. So reflection from concave mirror, to get the relation between R and F. Now my dear, what is R? R is the radius of curvature. R is the radius of curvature and F is the focal length, right? And we have to do this relation by using concave mirror. In the next topic, I will go for convex mirror. Now, so let us draw the concave mirror first. Now my dear, this is a concave mirror. No, it is not a concave mirror unless and until I make a polished. So in concave mirror, you all know, in my first video I have told you that the outer surface is polished and inner surface, this is the inner one, the inside one, the inner surface is reflecting. Okay. So this topic is not only give us an idea about what we are finding the relation. My dear, you should know what is concave mirror also from the topic. The concave mirror is a mirror in which the outer surface is polished and the inner surface is reflecting, and it will be look like this, right? Now there is a center called pole of the mirror and the straight line passing through the pole called as principal axis. So here, this is a straight line passing through the pole. I call this as principal axis. Okay. Now, my dear, assume that the parallel beam of light or parallel incident light, a light incident ray like this, say it incident at point M. I hope it is clear. And here is the direction, and I will mark here this as incident ray. Right? Let the name of the incident ray is A, and it is coming from some far object or some distant object. From distant object. Right? So this is the incident ray coming from some distant object, say from tree or from anywhere else. Say it is coming from distant object, and it will fall on the mirror at point M. And this ray is the incident ray. My dear, everybody have a knowledge of property. Now what is the first property? The property says that any ray which is parallel to the principal axis fall on the mirror after reflection. I repeat, reflection ke baad, after reflection it will pass through the principal focus. So let us see that what happened here. So after reflection, say this ray will pass through the principal focus. Here I will mark principal focus denoted by F. Right? So this is the ray which passed through the principal focus, and I marked it F, and this ray is my dear, you all know this ray is the reflected ray. Reflected ray. So you can see incident ray, you can see reflected ray. Am I clear? Now my dear, you must be knowing we have to draw the angle, right? For incident ray, it make angle I, that is called angle of incidence with the normal. And for reflected ray, it will make angle R with the normal, right? So angle I and angle R I supposed to draw in the figure. How I'll do that? Now my dear, for that, I have taken, say, a center of curvature. Here it's one more point I wanted to tell you. My dear, you can see here the ray reflected in this direction, right? The ray reflected in this direction. The ray does not reflected here. You can see. You must be thinking why the ray coming here, it not going there instead of coming here. My dear, you must be knowing, or from my video, please take care. Concave mirror is a converging mirror. Concave mirror is a converging mirror. I am writing here for your knowledge. So if converge, so where is the focus? Focus is here for concave mirror, because face of the mirror is like this. I told you all that if the face is like this, it's face. This is called face. So if the face is like this, the focus will be on this side. The center of curvature will be on this side. But if the face of the mirror is like this, like convex, and when I'll upload that video, you see that. When it will be the convex, like it's look like this way. Look at the face. So face is on that side. So focus and the center of curvature will be facing on that side. Right? In short, जहाँ face होता है mirror का, वहाँ पे focus होता है, वहाँ center of curvature होता है, क्योंकि face को face कर. Right? Similarly, convex में the face is like this, so focus and center of curvature will be on that side, on this side. Okay. Now, so since it is converging mirror, so what will happen? The ray will converge to focus, and focus is here, so the ray cannot go here. So that is the reason why the ray is not refracting here, my dear. Am I clear? So please take care. If anybody will ask you why the ray does not refract there, because it is a converging mirror, so it will converge to the focus. So focus is here, so ray will come in this side. Okay. Now, my dear, as I said, I need to mark angle of incidence I with incident ray and angle of reflection with the refracted ray. But then it is only the angle which is made with the normal and the refracted ray. So what should I do? My dear, let us draw the normal. In my previous topic also I told you, any ray which pass through the center of curvature. This is the ray passing through the center of curvature, and it incident at point M. Now my dear, this ray passing through the center of curvature is called normal ray, and it will be incident at point M and it will reflect back along the same path. Now here also there is one concept. Sir, you said, or I am telling you that the ray which pass through center of curvature in any diagram, if the ray passing through center of curvature, that is called normal. Why do we call this as a normal ray? You must be thinking. My dear, what is the story of this actually? That this is a mirror, sir. Okay, fine. This is a mirror. But mirror is a part of spherical surface. I hope you are knowing, because I have told you in my first lecture कि कोई भी mirror एक spherical surface का part है. And this center of curvature जो हमने बोला, this center of curvature is actually a center of the sphere. I can draw the sphere with this mirror also. You can see, I am drawing. I can draw the sphere with this mirror also. And this mirror is a part of this sphere. So this center is actually a center of the sphere, जिसका mirror is a part. फिर से सुन लो. Sir, mirror is a part of entire spherical surface like this. I can see. Right? Mirror is a part. And this C which I have drawn here, which I pointed here, is actually the center of this sphere. Like this. So if I draw any line passing through this C, that line will become the radius. That line become a radius. And you must be knowing, sir, radius is always fall perpendicular to the surface. Radius is always normal to the surface. And this is the reason why, my dear, the line which pass through the center of curvature are taken as the normal, because the center of curvature is actually the center of a sphere of which the mirror is a part. Now you can see, एक पहले sphere I have drawn, now it become a mirror. You can see. And hence I can say the line passing through center of curvature will fall normally on the mirror. Any line you can see in my diagram passing through center of curvature fall normally on the mirror, and the reason is that the center of the curvature which we marked here is actually a center of the sphere, and if I draw any line passing through center, it become a radius, am I clear, to the sphere, to the surface, and that sphere surface radius become a norm. And therefore, remember this, as line passing through center of curvature is always act as the norm. Okay. Now my dear, after this you can see that I am moving this. Okay, so I am rubbing this. Okay. Now here you can find, now if this line is a normal ray passing through the center of curvature, and again I am telling you why it is a center of curvature is taken as a normal, because center of curvature, actually center of curvature, this point is the center of the entire sphere of which this mirror is a part. सेंटर जो है पूरे स्फीयर का सेंटर है जिसका मिरर एक पार्ट है. सो इफ आई ड्रॉ अ लाइन फ्रॉम दिस सेंटर इट बिकम अ रेडियस ऑफ दैट स्फीयर and this radius is always fall normally on the surface. So this become a normal ray. So now my dear, here is the angle I, because this is the incident ray, and here is the angle R, because this is a refracted ray. Assume one more thing, let this normal ray, which you can see, this normal ray, let it make an angle of alpha with the principal axis. You can see the figure that it makes an angle of alpha with the principal axis. This is my assumption, that let this normal ray or the ray pass through center of curvature make an angle of alpha with the principal axis. Okay. So my dear, you can see the complete diagram. This is the complete diagram for this question, that I have drawn three ray which is required for any ray diagram, that is incident ray, normal ray and refracted ray. Now, and I mark the angle also, angle I, that is incident ray with normal, angle R, that is refracted ray with normal, and angle alpha, the normal ray itself make with the principal axis. Okay. Now my dear, you can see this part I don't require. So if I don't require this part, I am moving, because I can write here. The diagram is actually this much only. If I needed on that side, I would have drawn that side. But I don't need that side, so I am not drawing that. Okay. Now here you can see that what will be the distance. Now let us mark the distance. Everybody know, my dear, in my video lecture also I have given Cartesian conventions. You all know that we have to measure the distance from the pole, right? So first distance I am measuring from pole to principal focus. This is the arrow I am drawing. Look at the arrow ka head from this side, and look at incident ray according to my convention, sign convention. If the distance measured opposite to the incident ray, if the distance, this distance measured opposite, right, and incident ray is going like this, right? So incident ray is going from this side to this side, and the measurement which I am doing is from pole to focus this side. So no doubt, sir, this will be F, but it is denoted by minus F. In your SL Aurora book, it is given minus because they have not taken a sign property actually, because they were knowing that this minus and the minus over here also, one more minus will come and it become plus, therefore they have not taken. But I am taking from the sign convention also, I am applying sign convention also. Similarly, my dear, the distance from pole, that is this pole to center of curvature, that is still here, right, till here, this is your minus R. If this is minus R, this is minus R, because this distance is also measured opposite to the direction of incident ray. So this is the complete diagram for this topic. Now after this, let's start. How will we do for the derivation? How will you create the relation between R and F? Right? Where R is the radius of curvature and F is the focal length. Here, my dear, from figure you can see angle I in the figure is equal to angle R. Angle I and angle R are equal because of, you know why? Because of laws of, according to law of refraction. Okay, and I will put this as equation number 1. That is first point. Second point, now see properly. Can you see the line AM in the diagram? The line AM and the line CP or PC. I can say CP or I can say PC. I can say PF or I can say FP. No issues. No issues. I can say MF or I can say FM. No issues. Okay. So you can see in the diagram line AM parallel to line PC. Right? AM parallel to line PC. Right? Here also I am intimating from figure. So what will happen? If the two lines are parallel, 99%, 100% there is alternate angle is happening. Now here also you can see angle AMC. Angle AMC. How much is that angle? I. And is equal to angle. How much is that angle? I. Is equal to, you can see, angle MCP. Angle MCP. Can see M here, C here and P here. MCP. MCP. Right? MCP. Why? Because I and alpha become alternate angle. So this is equal to alpha. Right? It means that is angle I is equal to angle alpha. Okay, this is from figure. And what is alpha? Let alpha is an angle made by normal ray with the principal axis. पहले मैंने बता दिया I and alpha are equal, and then now I am intimating what is alpha. Alpha है क्या? So here I am writing in the bracket. What is alpha, which I have written up? So here I will put this as equation number 2. Angle I and angle R are equal. Angle I and angle alpha are equal. Now see, if I and R are equal, I and alpha are equal, don't you think from 1 and 2, can't we say angle I, or you can say angle R is equal to angle alpha? That is equation number 3. Because I and R equal, I and alpha are equal, therefore angle R and angle alpha are equal. Okay. Now, I hope 1, 2, 3 are clear. Now my dear, let us do one thing. Here one assumptions you are supposed to take. And what is that assumption? And remember this assumption for mirror. For mirror, if the question in the board, this question will be there in the board, write the assumptions for the mirror. It's an important one. And nowadays we have MCQs, so they are all important. So what is the assumption here? Let the aperture of the mirror is very small. You know aperture, that's a diameter. The mirror ka diameter, that is, this is a mirror. Am I clear? And the question and the assumption says, let the aperture means this, the diameter is very small. So if aperture is very small, then what will happen? All the point on the mirror surface, the surface point you can see are very close. Right? अब मैं बोलूँ मेरा हाथ इतना लंबा, right? अगर मैंने इसको कम कर दिया तो the point will come very closer. Right? So use that concept here, and please, that concept is very important. So I am writing here. Let. So this is my first point. Because you are writing your notes also, this is second point, this is my third point, and now I am writing the fourth point. Since mirror has small aperture, very important, since mirror has small aperture, hence point M and point P are very, I have written point PT, point M and point P are very close to each other. Close to each other. What assumption? This assumption of no kya fayda dega? Why I am taking this assumption? You know, if M and P are very close, then a distance from M to F and the distance from P to F will be equal. Because I said M is very close to P. तो जितना M से F होगा, M से F, उतना ही P से F होगा, because M और P बहुत नजदीक आ जाएंगे. Okay. Now my dear, here I have written angle R is equal to angle alpha. Can you see R and alpha are equal? Okay. What is the meaning of this if angle R and angle alpha are equal? This states that, here I will write, since, or here also I can say, if angle R and angle alpha are equal, if this and this are equal, then side CF, this side will be equal to side FM. The side, that is this side and this side will become equal. If these two angles are equal, angle R and angle alpha equal, then what will happen? Like isosceles triangle, right? Two opposite angles are equal, then two opposite sides will be equal. So here angle R and angle alpha are like this, they are equal opposite angles. So their sides, this side and this side will become equal. So that is side CF and side FM are equal, or I can say side MF are equal. Put this as equation number 4 and then proceed for this point. That is point number 4. So here, since mirror has a small aperture, hence point M and point P are very close to each other. What will happen to this? What will happen to this? If they are very close to each other, then what will happen, my dear? I said M and P are very close, so therefore side MF will be equal to side PF. जो MF था, that will be equal to PF because M and P are very close. And this is my equation number 5. So from, my dear, you can see side MF is actually side CF. Therefore, from equation 4, we get, what is side MF? Side MF is side CF also. Therefore, side CF is equal to side PF. Side CF, because CF was equal to MF. बट मैंने बोला कि अपर्चर बहुत छोटा है, सो M और P बहुत क्लोज है, तो जितना M to F होगा MF, उतना ही P से F होगा. दैट्स इंपॉर्टेंट. एंड देयरफॉर वी सेड अगर MF PF के बराबर है और MF CF के भी इक्वल था, तो CF and PF आर इक्वल. मतलब नाउ CF and PF आर इक्वल. ओके, नाउ इफ आई हैव टेकन दिस, लुक एट दिस from figure, point number 5. From figure, line, and I have taken line CFP. From figure, line CFP, you can see line CFP. So line CFP, you can say CF plus FP, CF plus FP is equal to CP. And from figure in line I am writing, from figure in line CFP, CFP line लिया मैंने, CF plus FP is equal to CP. But my dear, I have written CF is also equal to PF. So this become PF or FP plus FP is equal to CP, because that this is your equation 6. And here I am writing from equation 6. 6 में मैंने लिखा है CF और PF equal है, तो CF के जगह पे I have written FP because I told you either I say PF, either I say FP, no issues. So this is 2FP is equal to CP. You can see this is 2FP is equal to CP. Therefore this will be 2, and FP is how much? Here you can say minus F is equal to minus R. So this will gives you minus 2F is equal to minus R. Minus and minus cancel, which gives me therefore R is equal to 2F. I hope it is clear, right? So you can see the formula R is equal to 2F, and hence we can say F is equal to R by 2. So this is the relation between R and F. So my dear, always make a note of this, that whenever you take this topic, remember this, there are two important concepts. One is a converging mirror, is the concave mirror. So reflection will take place, that is, it will converge to focus, and focus is on this side, so it will be, the rays will come on this side. This is one thing. Second, angle I and angle R are equal. Line this and line this are parallel. So my dear, if this line and this are parallel, then this angle I will be equal to this alpha also, that is alternate angle. And since I and R are equal, I and alpha are equal, so R and alpha will be equal. This is point number 3. And third point, after knowing this, कि R and alpha are equal, जब ये angle और ये angle equal हो गया, which means that this side, the side CF and the side MF will be equal if this angle and this angle are equal. So that's what I have written, that side CF is equal to side MF, like this. And then I will go for the next, a very important assumption, that the mirror के पास में has a very small aperture. So if aperture is very small, M and P are very close to each other. So what will happen to that? If the distance MF, since MP are very close, so the distance MF will become equal to distance PF, which I have written here. And then, since earlier also MF is equal to CF, so from equation 4, we will come to know that PF and CF are equal, because MF is equal to CF in this equation. Right? And then I have taken the last point as that, take a line CFP, right? Take a line CFP in which CF plus FP is equal to CP, right? That is CF plus FP, but CF is equal to FP, right? The CF is also equal to FP, so this becomes FP plus FP, that is 2FP is equal to CP, and FP is how much? FP is now how much? FP is minus F, so this will be 2 into minus F is equal to minus R. Am I clear? And here if I go for this, this is minus 2F is equal to minus R. Minus and minus cancel, R is equal to 2F. You can see here, my dear, R is equal to 2F. Therefore, you can say, what is F? F is equal to R by 2. So this is the relation by using concave mirror, which is a converging mirror. In the exam, the question can be like this, that by using converging mirror, they will not mention the name. Look, try to understand the 12th standard question nowadays. By using converging mirror, derive the relation for R and F. So by using converging mirror means they are talking about concave mirror. Okay, thank you very much. In the next video, I will give you a knowledge of reflection from the convex mirror. Reflection from the convex mirror. Thank you all. Jai Hind. Thank you.